Okay, today we're going to look at the basic function of a transistor. Transistor is a very important electronic component which is behind a lot of latest electronic technology. So it is an active device. There's a base, collector, emitter here. The base is acting as a control. It can control how much current flowing between the collector and emitter. In this particular circuit, we have a light bulb and a transistor here. So the light bulb is connected to the positive end of the battery, and then the emitter of the transistor is connected to the negative. So basically, this is the main part of the circuit, the light bulb, a transistor, and then go back to this negative. And whether this light bulb can be turned on depends on this part. The base of the transistor is kind of behaving like a switch. It can control whether the light bulb can be turned on or how bright is this light bulb. We're going to look at how this circuit works in this diagram. I built a simulation on Tinkercad using this circuit. And here's the battery, 9-volt battery, and this round thing is a potentiometer. Basically, is trying to tap a voltage. When I turn this knob, the position of this arrow change. It depends on the position of this connection. If it's connecting to the top, it's closer to the 9-volt end, so you have higher voltage at this end. When it's connected to the bottom side, it's closer to the 0-volt. So by adjusting this potentiometer, I can adjust the voltage here. And the voltage at this point determine how much current can flow through from the base to the emitter, which control the current here. All right, so it's easier to just look at how this circuit works first, and then I'll explain to you the details of the operation of a transistor in this circuit. I click simulation, and now you can see that the light bulb is already on. So if I turn it to the far end, so this is the this bottom end. In that case, the voltage is close to 0, and that's why you can see the light bulb is off. When I turn the knob here, you can see that the light bulb is turning on and getting brighter, and it's brightest when I turn it to the top end of this potentiometer. So it is a simple circuit that can be used to control the brightness of a light. And this resistor here is to limit the current flow to the base of this transistor, because we don't need a lot of current to flow through. If too high a voltage is applied to the base, and if the current is not limited, it can easily burn a transistor. So that's why we have a resistor here to limit the current flow to the base of this transistor. In order to study the circuit in a bit more detail, I'm going to add a ammeter here to check the current flowing through the light bulb, and add an ammeter here to measure the current flowing through the base of this transistor, and also add a voltmeter across the base and the emitter to see how the voltage change. Now I have connected a ammeter here on the positive power rail. We're going to measure the current flowing from the positive terminal to the light bulb. and I connect another ammeter between the resistor and the base of this transistor. Again, I'm measuring the current. In this case, is flowing from the base to the emitter. So this is somewhere is an emitter here from the base to the emitter, and this voltage is measured by the voltmeter here connected between the base and the emitter. Now I start the simulation and you can see all those numbers changing. Right, so now the light bulb is half turned on, and you can see as a current 17.1 milliamp, and you find it's negative because I connected in the wrong way, but it doesn't really matter. It just showed me a negative. If I connect it in correct way, the connection here will look a bit messy, and that's why I just purposely leave it as negative, and I know that the current is flowing from left to right instead of right to left. So that's why it's a negative. Is 17.2 milliamp. Milli means a thousandth of an ampere. And here the base current is 58.2 microamp. So this current is basically about 500 times smaller than the current flowing here. So you only need a tiny amount of current to trigger the current flow from collector to base. All right, so the bottom one is the voltage between the base and emitter. You find that this voltage changed just a little bit in this whole control circuit. So I start from here. You find that initially it's nothing because the voltage here is 0. So that's why you measure the base to the emitter 0. But when I adjust a little bit, you find that current start to flow from base to emitter and build up a tiny bit of voltage, 631 millivolt, which is a 0.6 of a volt. When I keep increasing the voltage at this end, you'll find that the current increased quite a lot. Right, I start from 0, and then gradually increase the current. So you'll find that it's follow closely to the position of this potentiometer. Right. So now, when this potentiometer change the voltage here, the current through the base change, and that little bit of current is controlling how much current can flow through the collector and emitter, and that is the current flowing through the light bulb. So this is how this circuit control the brightness of the light bulb, right? So you can build this circuit yourself and play with it and learn a bit more. You can try different configuration and see how it goes.